is not a product. Okay, so it is false. What is false? The reason is because command A is a function and A is angle. Okay, so it cannot be separated by product. Okay, now sin theta is equal to 4 by 3 for some angle theta. Sin theta is equal to 4 by 3 for some angle theta. Is that true? Is that true? What is sin theta? Opposite by hypotenuse. Look at the hypotenuse value 3. Look at the opposite value 4. You know that in a triangle, opposite value must be greater than other. Hypotenuse value must be greater than other two sides. Whereas in this, they are given hypotenuse is equal to 3, opposite side will be 4. This is possible? No, this is not possible. And you can take that if you divide 4 by 3, you will be getting 1 point something, right? So you know that sin theta value will not rise more than 1. It is always less than 1. So you can observe here is we are getting more than 1, right? So this is not possible. This is false. Because the value of sin and the value of sin A, the value of sin A is always less than 1. Value of sin A is always less than 1. Okay, so this they may ask for the multiple MCQs. They can make use of the multiple choice questions by using these true or false. So these are the true or false questions. Okay, so now as I have given you homework to you, so question number 5 and 6 I think I have given the homework to you, right? Yeah, 5 and 6 I have given the homework to you. Of course, fifth one you can easily find out. Second theta they have given. Calculate all other trigonometric ratios. Hope you have done that. Sixth one will be a tricky question. Okay, so I will do the sixth one. Fifth one, you know we have to do that because in the whole episode I have given only one homework that we have to do that. Okay, so sixth one I will do it now. Okay, we will go for sixth one now. Okay, so the sixth question is, if angle A and angle B are acute angles, acute angle since it is less than 90 degree, more than 0 degree, 0 to 90 degree, okay, such that cos A is equal to cos B, cos B is equal to cos B, cos of angle A and then cos of angle B both are equal, then we need to prove that angle A is equal to angle B, angle A is equal to angle B, okay. So here we have a cosine function and A and B are the acute angles. We need to consider what? We need to consider a right angle triangle. We need to consider a right angle triangle. Let us consider a triangle. Let us consider a triangle ABC such that CD is perpendicular to AB. CD is perpendicular to AB. Let us consider triangle ABC such that CD is perpendicular to AB. So let us consider triangle AB. Okay. So A is a acute angle. So I will take this as A, this as B, and this as the CD. I'm sorry, ABC is the triangle in which CD is perpendicular to AB. CD is perpendicular to AB. Then only we will form two right angle triangles. Okay, I can use the cosine function. Now this is angle A and this is angle B. Now ABC or ACD is one triangle and BCD is another triangle. Okay, ACD is one right angle triangle and CBD is another right angle triangle. We have two triangles. We have converted. Initially, we have taken ABC, one triangle, and we have converted into two triangles, two right angle triangles. cos B. Okay. Now what is cos? Adjacent by hypotenuse. Angle A, cos angle A. So this is angle A. Now considering triangle ACB for the cos function, which is hypotenuse, AC is the hypotenuse, AD is the adjacent, CD is the opposite, because this is opposite, right? Now for the cos A, we know that it is opposite to adjacent to hypotenuse. This is with respect to angle A. So if I write in the bracket, it will give different meaning. So you can observe that it is adjacent to angle A, hypotenuse to angle A. This is cos A. Okay. So which is adjacent? Here also you can write adjacent. Okay, in the bracket I will write. Okay. This is hypotenuse. This is adjacent to angle A, adjacent to angle B. Okay. So now which is adjacent to angle A? This is angle A. Which is adjacent? AD. AD is the adjacent, right? Okay. Which is hypotenuse? AC. LHS. Okay. Cos B, then considering angle B, which is adjacent. BD is the adjacent. Okay. BD is the adjacent. Hypotenuse is for this triangle BCD. BC is the hypotenuse. Clear? Understood this? Cos A with respect to angle A, adjacent A, hypotenuse. We should take this triangle, only this triangle, ACD. I'll write it separately. ACD. Then BDC. Okay. Now we considering angle A. Okay. So this is hypotenuse, this is adjacent, this is opposite. Correct? With considering angle B, this is opposite, this is adjacent, this is hypotenuse. Clear? So like that we have taken adjacent A, AD. AD is the adjacent. AD is the this is not D. This is C. This is C. This is D. Okay. Now AD is the adjacent. Then AC is the hypotenuse for the cos A. Okay. For the cos B, BD is the adjacent. BD is the adjacent. Then BC is the hypotenuse. Clear? Now this is equal. I'll bring BD to this side. What will happen? BD is here. It is in the numerator. If you send it to the other side, it comes to denominator. Correct? And as usual, I'll send the AC to other side. The AC is divided here. If I send it to other side, it will be multiplied, right? So it goes to numerator. These two will be going to be interchanged. Okay. So AD by BD is equal to AC by BC. Okay. Clear? So BD and AC, since these two are equal, they are interchanged. Right? Now AD by BD is equal to AC by BC. Since these two ratios are equal, I will take it as K. That ratio, that value as K. Okay. So these two are equal, since these two are ratios, I will take it as a K. K is some positive integer. Okay. Now I will equate this ratio to the K as well as this ratio to K like this. This implies that AD by BD is equal to K. Okay. AD by BD is equal to K and AC by BC, individually I am equating. AC by BC is equal to K. Since these two are equal, those two must be equal to some constant. Right? Now this is equal to K and this is also equal to K because all these are equal. This we have studied in the linear equation two variables, pair of linear equation two variables, cross multiplication method. Right? When those two are equal to something, then we will be equating individually. Right? The same concept here also. Okay. Now, so AD by BD is equal to K. So AD is equal to K times. If I cross multiply K into BD, K into BD. So call this as equation 1. Call this as equation 1. I have cross multiply. AD by BD is equal to K. So AD is equal to K into BD. Like this. X by 2 is equal to 4. So X is equal to, if I cross multiply 2, it will become 8. That is 4 into 2. Is going to be multiplied over there, right? Similarly, AD is equal to BD into K. That one also. AC is equal to K into BC. All this is equation 3. Right? AC is equal to K into BC. Okay. Now, the Pythagoras theorem for triangle. Using Pythagoras theorem for triangle. Okay. So this is A, B, C, and A this triangle. This is A, B, C, this is D. Okay. Individually, if I take C, A, D, right angle, C, D, B, right angle. Okay. Now I need to use the Pythagoras theorem for triangle ACD and this one also. Triangle BCD. Okay. I'll write it. I'll use the Pythagoras theorem. I'll keep equation 1 and 2 as it is because it is required. Okay. So I'll be using the Pythagoras theorem for triangle ACD. So this is hypotenuse side. Okay. So AC square is equal to, which gives AC square is equal to AD square plus CD square. Correct? If I use for first triangle. Okay. So if I simplify this, I will keep CD square here only. I will bring AD square to this side. What will happen? AC square is equal to AC square minus AD square is equal to CD square. Okay. Or I will write LHS and RHS and RHS and LHS. CD square is equal to AC square minus AD square. Call this as equation 3. What I have done? I have used the Pythagoras theorem for the triangle ACD. So AC square is equal to AD square plus BC square, because AC square is the hypotenuse side. Okay. Then I will be keeping CD here only. I will be transposing AD to LHS. It will become minus AD square. So AC square minus AD square is equal to CD square, or CD square is equal to AC square minus AD square. LHS is RHS, RHS is LHS. I am not transposing. I am just writing LHS and RHS. I am reverse LHS. Okay. Now, similarly for the triangle BCD, if I use for BCD, then BC square is equal to BD square plus CD square. Correct? Also, BC square is equal to BD square plus CD square. Correct? BC square is equal to BD square plus CD square. Again, I am bringing BD to this side. So it is BC square minus BD square is equal to CD square, or CD square is equal to BC square minus BD square. Call this as equation 4. By looking the equation 3 and 4, you can observe the LHS, CD square and CD square. LHS is CD square and CD square. Same. So that RHS must be equal. That is AC square minus CD square is equal to BC square minus BD square. Right? So if LHS are equal, RHS must be equal, right? So from 1 and 2, from 3 and 4, okay, from 3 and 4, we know that AC square minus AD square is equal to BC square minus BD square. Okay? Since LHS are equal in 3 and 4, RHS must be equal. AC square minus AD square is equal to BC square minus BD square. Okay. Now, in the LHS, we know that AC is equal to KBC. AC is equal to KBC, I will substitute. AD is equal to KBD, I will substitute from equation 1 and 4. Okay. I will write, substitute AC is equal to KBD and AD is equal to AC is equal to KBC, AD is equal to KBD. Okay. Okay. So substitute AC is equal to KBC and AD is equal to KBD from the equation 1 and 2. This is 2. This is 2. From the equation 1 and 2, because AD is equal to KBD, AC is equal to KBC in the equation 1 and 2. I am substituting in this equation. Let's see what will happen. Okay. So if I substitute AB is equal to KBD, AC is equal to KBC. So KBC whole square minus AD is equal to KBD. So KBD whole square. Okay. RHS BC square minus BC square minus BD square. BC square minus BD square. So this is if you split the square, K square BC square. You can't even split for B square C square. BC is not a terms. BC is a side. K is different. K is some constant. It is some positive integer. Whereas BC is a length side. Okay. It is measuring of the side. So you can't even split for B and C. B square C square. It is not possible, right? Otherwise you can write like this, BC whole square. Okay. So then K square BD square. So this is BC square minus BD square. Okay. Now K square is common. I can take it outside. So what is remaining inside? BC square minus BD square. In the LHS, RHS I have BC square minus BD square. Okay. Now I'll keep K square here only. Okay. K square into BC square minus BD square. So this is multiplied. If I send to the other side, it will get divided, right? So here I get BC square minus BD square. Okay. This is multiplied with the K square. If I send to the other side, it will get multiplied. It will get divided, right? So BC square minus BD square. So BC square minus BD square minus BD square will get cancelled. Both sum in the numerator, denominator, both values. Okay. So this 1 divided by 1 will become 1. So K square is equal to 1. This implies that K is equal to 1. K is equal to 1. So K square is equal to 1. So therefore K is equal to 1. Okay. So this K will substitute in the equation 2. So K is equal to 1, right? We substitute that K is equal to substitute K is equal to 1 in equation 2. What is equation 2? AC is equal to K times of BC. Okay. So AC is equal to, if I substitute the K value 1 into BC. So that means AC is equal to BC. So what is the triangle initially we had? We had a triangle A, B, C. From the C we have a perpendicular. Okay. So AC is equal to BC. What it concludes? What is that? AC is equal to BC. AC is equal to BC. So in the class line we have studied that these are the sides AC and BC. Those two are equal. We have concluded that AC is equal to BC. That means these two sides are equal. That means these two angles are equal. Why? Angles opposite to equal sides are equal. That is, we have studied the theorem, right? If these two sides are equal, then these two angles are equal. Then if these two angles are equal, then these two sides are equal. That is, we have studied. Angle opposite to equal sides are equal. Sides opposite to equal angles are equal. Right? We have studied as a theorem, two different theorems. Right? So you can observe that we have concluded that AC is equal to BC. AC is equal to BC. That means angle B is equal to angle A. Angles opposite to equal sides are equal. That means angle A is equal to angle B. Okay. So in the bracket you can write. Okay. Angles opposite to equal sides are equal. This is what we need to do. We have proved. Okay. So we need to do it very carefully. Calculation and when taking the Pythagoras theorem, we should bring it to C square. So both will be in terms of C square. Both will get cancelled. It will simplify away. AC is equal to BC. Okay. So that's it. It will complete the exercise 11.1. So in the next class, we will go for the next concept in the trigonometric lesson. Okay. So any doubts, you can call me, or else you can get back to me through you can message me. Okay. So thank you.